Hello students, Professor Smolny here, talking about special topic number 2, which is going to be on AI specific programming languages, or programming languages that are used to tackle some common obstacles in artificial intelligence programming, programs in which you're going to have um, the need to capture information and have either create an agent or have an agent access this information. So there are two specific languages I'm going to talk about tonight. One being Scheme, which focuses on using lists and recursion to allow for simple programs that take user input and um, basically allows us to parse out the items from that input and act accordingly. And the other is Prolog, which is a programming language that focuses on the storing of relationships and rule sets that can help trigger off other pieces of code. Um, so let me dive into the first one here, being Scheme. So Scheme, as I mentioned, is a language that focuses around lists. And so it has a little bit of an interesting schema or structure where all the operators in the code itself are first, followed by the parameters. And so you'll see here we have some sample code with different functions, and so the function name is always first. One of the good or most useful pieces of Scheme is that the return values from functions can be used as parameters once again. Regardless of type, you don't really have to cast anything in Scheme. And so this allows us to create very easy to understand recursive programs that can help parse through content very quickly and very easily. So I guess I want to go over a couple of the more well-known built-in functions inside of Scheme. So I'll just run through these pretty quickly. Cons takes 2 arguments and returns a pair, a list of those. So in this case, if we wanted to create a list from 2 separate numbers, now we have a new list, so you just call cons 1, 2. If you have 2 separate lists, you can do that. If you have 2 lists that you want to actually have one embedded the other, you can do that as well. The next function is car, which will return the first member of a list. So this is if you want to kind of like pop off the first member of the list to evaluate it, you can do that. The next is CDR, CDR, however you want to say it, which will basically return the list without the first item. So you might have a program that evaluates the first item in a list with car and then recursively calls the same function on everything else by using CDR. Null, yeah, I think that's pretty self-explanatory. It's a null list. List returns a list constructed from its arguments. Pretty self-explanatory once again. And then there's a couple of functions that are built in: length, reverse, append. Append is obviously a lot like the first cons. Returns a list that appends the 2 separate lists as arguments. Once again, there's your standard logic. And so let me just kind of give you an example of what you're able to do with Scheme. Let's take a look at a couple sample programs. So this first one, length, is actually another implementation of the built-in function, but it gives you a good idea of what exactly can be done. So we're finding a new function called len, right? And this function is going to take one parameter, x. So what does this function do? Well, first off, it has a condition. If x is null, the length is 0, right? Pretty simple. Otherwise, if it's not null, the length of the list is 1 plus the length of the list minus the first object. So basically you're just popping it off letter by letter and adding 1 each time. So recursively, what you're going to find out is it's 1 plus 1 plus 1 plus 1 until you get down to 0, and then it'll return the sum of all of those individual letters as the full length. So you'll notice that this is another operator, addition. So like I said, you don't have to typecast here. So as I'm getting the sublists evaluated one by one, they'll automatically get evaluated when they come back up recursively through the loop, and you won't have to do anything special here. So you can see this is very, very clean code once you understand the language syntax. That's pretty much all I have to talk about for Scheme. Really, what you might want to use Scheme for, like I said, is parsing out user input. You could see this as being a way to kind of evaluate sentences, parsing out what the different different pieces of a sentence might be. So whether it be a noun, a verb, you can figure out how you would take actions based on the input there. You could also kind of once again, you could try and make natural language parsers using Scheme fairly simply, and get decent results. There's also some plugins for other languages, so C and Java, so you can have a program written in Scheme that can interface well with other languages. So that's really the strengths of Scheme. Let me just see if there's anything else I want to touch on before I move on to Prolog. And I'll send you guys some links for some tutorials relative to Scheme. So I think you'll see in the next language, Prolog, that the uses of it are a little bit clearer as they relate to AI. So Prolog is a language in which you define certain relationships. So I'm just going to jump into an example to explain what the heck that means. So let's say you have a function sibling x and y. So you have two parameters, x and y. If this is true, if x and y are siblings, then they will share a parent. So you could define another function, parent-child, the parent-child relationship. So z is the parent of x, x is the child of z. It's the same relationship. So in order for x and y to be siblings, they have to share some parent z, right? And parent-child could also be defined as father-child or mother-child. So it doesn't matter if your father or your mother were the same person. If you shared one of those two, you would be siblings. So you could then, based on these rules, take some known set of information, mother-child, Trude, Sally, father-child, Tom, Sally, father-child, Tom, Erica, father-child, Mike, Tom, and then run queries on this information, like, are Sally and Erica siblings? Well, the answer is yes. Now let's look through our rule set and figure out why. Tom is both the father of Erica and Sally, right here. So rather than having to try and really clearly define functions around this, you kind of are just really high level entering information about